Hello dear friends, once again. Okay, check. Let me check the voice once. Okay, just give me 1 minute. Hello, hello, hello. Am I audible? Hello dear friends, welcome back to MACSGATE. We are learning probability and this is the fourth session on probability and statistics part 1. I actually divided this probability and statistics into 3 parts, and this probability and statistics part 1 is common to all branches. There are 2 more parts, part 2 and part 3, where I'll be discussing bivariate distributions and sampling distributions separately. Am I clear? So here probability and statistics, which we generally call it as probability, which is common to all branches, and it is also common to data science and artificial intelligence. Okay, so let us start with today's session. Of course, the title is addition theorem, but we need to complete one more topic under combinatorial probability, that is combinations with repetitions. So let me introduce that particular idea to you. Then after completing it, I start today's session, that is addition theorem also will be discussed. Hope you understand. Very good. So combinations with repetitions. So number of combinations of n distinct objects taking r at a time, when each thing may be repeated any number of times. That is r combination of n objects where the objects can be repeated. And that is given by the formula n minus 1 plus rcr. So what I do is I first give you one example to explain the idea, then I'll give you the formula and we solve more problems on that. Consider it is only combination question, it is not a probability question, sir. Suppose number of ways of selecting 10 fruits from mangoes, oranges and apples. We want to select 10 fruits from mangoes, oranges and apples. How can you select 10 fruits from 3 fruits? Obviously, it is possible only when there is a repetition of the fruits. So here we are having mangoes, oranges and apples, and you want total 10 fruits to be selected. So you may be selecting x1 mangoes, x2 oranges and x3 apples. So you want to solve this particular equation where each xi, that is x1, x2, x3, that is number of mangoes, number of oranges and number of apples can be greater than or equal to 0. And this result which I given, it is like, you know, number of ways of selecting n objects. So you want to select n objects from r distinct objects. That is what you want to do, sir. Okay, so here you want to make, r selection. You want to make a r selection. That is, you want to select r objects from n objects. So it is the first object, second object and so on, nth object. So I may be selecting x1 of the first type, x2 of the second type and so on, xn of the nth type. So I want to solve this particular equation x1 plus x2 plus and so on, xn is equal to r, where each xi is greater than or equal to 0. Whenever you can write your problem as, or interpret your problem as this particular problem, the solution for that particular problem is given by n minus 1 plus rcr. Of course, the derivation is little involved, so I am not getting into derivation. But when I do combinatorics for computer science students, the derivation of this rule also will be given. Okay, maybe I come up with a separate session on combinations with repetitions, where I'll be discussing the derivation of this particular formula. Generally, I discuss that under discrete mathematics. Hope you understand. But if you remember this formula, you can easily solve the problems, my dear friends. So whenever you are having this particular equation x1 plus x2 plus and so on xn is equal to r, where each xi is greater than or equal to 0. The solution for that is n minus 1 plus rcr, where n is number of objects with repetitions, r is the selection which you want to make, that is you want to make a r selection. Then the number of ways of making r selection from n objects with repetition is given by n minus 1 plus rcr. Actually people also write it as n minus 1 plus rc, n minus 1 also they write it, but it will create some kind of confusion. Generally what we tell is, when r is smaller you use this formula, when n minus 1 is small you use this formula. Actually the idea is very simple, because you all know, right, NCR is equal to NC n minus r. So it is n minus 1 plus rcr is actually same as n minus 1 plus rc, this fellow minus r. So this r get cancelled and you are going to get this formula. So if you know this formula, obviously these two are one and the same, we understand that. Is that clear? So that is the idea, my dear friends. So now what is the answer for this? Here you need to identify what is n, number of objects, that is 3 objects or 3 fruits in this case, and r is 10 selection you want to make it. And here please note, this condition is very important. If xi is greater than or equal to 0, then only the formula is applicable. Then only the formula is applicable, that is n minus 1 plus rc r. So what is n here? 3 minus 1 plus r. R is 10, c 10. So that is 12c10, my dear friends. And you all know 12c10 is exactly same as 12c 12 minus 10, that is 12c2. Whichever is simple, you can solve that. So what is the answer for this? 12 factorial by 2 factorial into 12 minus 2 factorial, that is 10 factorial. So that is nothing but 12 into 11, because 10 factorial cancels and you get by 2. So it is 66. So how many ways you can select 10 fruits from mangoes and oranges and apples? That can be done in 66 ways, my dear friends. That can be done in 66 ways. Very good. So now you understand. Let us use this to solve a problem. Here 15 fruits are selected from mangoes, oranges and apples and grapes, 4 types. We are selecting 15 fruits from 4 types of fruits. What is the probability that the selected fruits are of same type? All the selected fruits are of same type. So you are selecting 15 out of 4 fruits. So first type you can say x1 mangoes, x2 oranges, x3 apples and x4 grapes, and where the sum should be equal to 15, because there is no condition mentioned that each object should be, because total I am finding. When I am finding total possibilities, there is no restriction. So how many total possibilities are there, sir, where each xi is greater than or equal to 0? And in this case, what is the value of n? 4. What is the value of r? 15. So what is the answer here, sir? n minus 1 plus rcr. That is 4 minus 1 plus 15 c15. That is 18 c15. So you can simplify this. That is 18 into 17 into 16. 15 factorial, 15 factorial gets cancelled. Okay. And 18 minus 15 is 3 factorial. So 3 to 6, 6 3 is 18. So you can simplify further, my dear friends. Whatever answer you get, that is the total possibilities. But what is that you want? Here you want probability that the selected fruits are of same type. Selected fruits are of same type. See, what do you mean by selected fruits are of same type? That is, what about the favorable situation here, sir? You want all the, because you want to select 15 fruits. So you want all the 15 fruits to be mangoes, or all the 15 fruits to be oranges, all the 15 fruits to be apples, or all the 15 fruits to be grapes. That is 15 0 0 0. This is one situation. Or 0 15 0 0. This is second situation. 0 0 15 0. That is, we are selecting from this, so the total is 15. Or 0 0 0 15. So how many favorable situations, Babu? Only 4 favorable situations. There are only 4 favorable situations. So what is the probability for this? 4, that is favorable, divided by total. Total is, you can do it like 3 into 17 into 16. We'll do simplification later. 3 into 17 into 16. So 4 fours. So now it is 1 by 12 into 7. 12 into 7. Or you have calculator? You can do that calculations quickly, my dear friends. Those who are having calculation can do that. 170 and 34. That is 204, I think. Please verify. Am I clear? So the answer is 204 here, my dear friend. 1 by 204. That is the probability for this. You can try different problems. Please note, whenever you are making selections with the repetitions, you need to know how many objects are there, that is n. How much selection you are doing, that is R selection, that is the value of R. Okay. And if there is no restriction, like each object can be selected or not selected also, that is each xi is greater than or equal to 0. In such case, the number of R combination of n objects with repetition is given by the formula n minus 1 plus RC R. Please note this formula, you can easily get the answer. As I told you, I'll try to come up with a separate session where I'll be discussing the details of this particular formula. Actually, this particular, combination with repetition is a very, very interesting formula, my dear friends. We have, almost 4 to 5 different forms of this particular formula. But generally, for under probability statistics, they'll ask you, so far what they asked is very basic questions. So I just going with a very basic questions. Whereas for computer science students, we have topic called combinatorics, where we discuss these formulas in more detail and we solve more problems. Okay. So when I come up with that counting techniques separate topic, there you can see where I'll be solving more problems. Is that clear? Yeah. One more question. As I told you, this is one of the gate question. Candidates were asked to come to an interview with 3 pens each. So candidates were asked to come to an interview with 3 pens. Black, blue, green and red were permitted pen colors. So the candidate can come up with a black pen, blue pen, green pen, red pen. These are the permitted colors. And he need to come up with how many pens? 3 pens. So now generally what happens when you see from 4 you need to select 3 pens. What generally people feel here is this can be done in, how can you select 3 pens from 4 types? 4C3 ways. So this is what people feel. Generally that is what people feel. So they feel that 4C3 possibilities. But please read the question carefully, then you will understand whether it is with repetitions or without repetitions. This is the situation when it is without repetition. But if you observe or if you read the question carefully, find the probability that a candidate comes with all 3 pens having same color. Means what? He may come up with all 3 blue pens or all the 3 black pens or all the 3 green pens and all the 3 red pens. So he is asking probability with repetitions or not probability, combinations with repetitions he is asking. Am I clear? So we need to find combinations with repetitions. So here we are having, let us say, black as x1, blue as x2, green as x3 and red as x4. This is what you want. So we want to select 3 pens from 4 types where repetitions allowed. So this is the total possibilities. This is the total possibilities. Combinations with repetitions where each xi is greater than or equal to 0. So what happens to this? Here n is equal to 4, r is equal to 3. What is the answer for this? N minus 1 plus rc r. That is 4 minus 1 plus 3c3, which is nothing but 6c3. That is 6 into 5 into 4, 3 factorial cancel, one more 3 factorial will be there. That is nothing but 20. So this is total number of possibilities. We are having 20 total number of possibilities. How many possibilities we are having, sir? 20 total number of possibilities. Super. Now what is the favorable situation? You want all the 3 pens to have same color. What do you mean by this? You may have all 3 black pens and remaining 0, or you may have 3 blue pens and remaining 0, or you may have 3 green pens and remaining 0, or you may have 3 red pens remaining all 0. So how many favorable situations are? 4 favorable situations. So what is the probability that the 3 pens having same color, or candidate comes with 3 pens with same color. So favorable by total, which is nothing but 1 by 5. 0.2. So that is the answer for this problem, my dear friends. Is that clear? Okay. See, if you want, you can write down in a more detailed manner, my dear friends. You can just identify what are the possibilities. How can you get these 20 possibilities? Okay, because you want, let me just take this. I'll just show you. For example, if you want this, like, you know, what are the 4 colors? I forget the colors names. Okay, black, blue, red and green, or green and red, whatever orders are. So you want to make a 4 selection. Okay, you want to make a 3 selection. Okay, so what are the possibilities, my dear friends? You can try to identify. You may select 3 of this 0, 0, 0. Am I clear? Or that is, this may be 3, or here you may have 3. That is, all the 3 of same type is one possibilities. That is, suppose if you do not know the combination formula also, you can solve it. Generally in GATE, whenever such questions are asked, they ask very basic level where you can do it by listing also, or by understanding the idea also. The other possibility is 2 of one kind, then 1 of the other kind. The 1 of the other kind can be like this, or you may have 2, 0, 1, 0, or you may have 2, 0, 0, 1. Now this is for when you select 2 black balls, but the same thing can be done for 2 blue balls and 2 green balls, 2 red balls also. So here we are having 3, and how many such possibilities are there? This is for black. So we are having such 4 different possibilities. That is, selecting 2 blue balls, again we get 3 different possibilities. So totally we are having 12, and it is 4 possibilities. Then you may select 1, 1 of each type. That is 1, 1 of each type. And how many such cases are there, sir? You have to keep 3 ones in 4 places. That is 4C3. That is 1, 1, 0, 1, 1, 0, 1, 1, or 0, 1, 1, 1. 4 cases. Total how many? 20 cases. If you want to see what are the 20 cases, you can see like this. So whatever I said, this 20, you can also list like this. But it would be a long procedure, my dear friends. Please try to understand. Next one. This is a very interesting story. 3 indistinguishable, similar. They may say indistinguishable, ya to similar. Pair dice are rolled simultaneously. Find the probability of getting equal outcomes. What about the probability of getting equal outcomes? This is the question. We are rolling 3 indistinguishable fair dice. Okay. What is the probability of getting equal outcomes? See, my dear friend, normally when dice are rolled, when they are distinguishable, when you roll 3 dice, 6 cube possibilities are there. But here they are similar dice. So when you roll the dice, you may get the outcomes 1, 2, 3, 4, 5, 6. These are the outcomes you may get. See, when you roll it 3 times, you may get 1 2 times and 3 1 time, remaining you don't get it. So when you add it, you are going to get 3 value. Or you may get 1 once, 2 does not appear, 3 does not appear, 4 appear, and 6 appear. But if you add all of them, you are going to get 3. That is, 3 dice are rolled. The outcomes you may get are like 2 1s and 1 3. Or you may get 1 1, 1 4, 1 6. These are the different possibilities. That is, you may get 1x1 times, 2x2 times, 3x3 times, 4x4 times, 5x5 times, and 6x6 times, so that sum is equal to 3, my dear friends. Sum is equal to 3, my dear friends. Where each xi can be, you can have 0 or more times. So what is this? Here n is equal to 6 and r is equal to 3. So what is the formula for this? It is combinations with repetition. So what is the formula? N minus 1 plus RCR. That is 6 minus 1 plus 3C3. That is 8C3. So when 3 fair dice are rolled, or similar dice are, indistinguishable dice are rolled, we are not going to get 6 cube outcomes, sir. We are going to get only 8C3 outcomes. Am I clear? What is it? 8 into 7 into 6. 5 factorial cancels by 3 factorial. This 3 factorial cancels with this 56. So this is total possibilities, my dear friends. When 3 similar ya to indistinguishable dice are rolled, there are 56 possibilities are there. Now what is that you want? What is the probability of getting equal outcomes? Equal outcomes means what, sir? You get all 3 ones, or you may get all 3 twos, or you may get all 3 threes, all 3 fours, all 3 fives, all 3 6. That is, you may get 3 remaining all 0, or you may get 0 remaining all 0. So continuing this way, you may get all 0 and 6 3 times you may get. This is 1, 2, 3, 4, 5, 6. Is the idea clear? So how many such cases? 6. So how many favorable cases for this, sir? 6 favorable cases. So what is probability of getting equal outcomes? Probability of getting equal outcomes is given by favorable divided by total, 56 by 6. See, for gate examination, for probability, if you understand up to here, you can easily answer the questions, my dear friends. Is the idea clear? So this is about the combinatorial probability. We understood the basic idea. Now, if any question comes, read the question carefully, understand, okay, and try to convert that problem into the given category. Okay, it is reduction. We call it as reducing the problem to a given formula or form. Once you reduce it to that particular form, the formula will take care of the rest of the story, my dear friends. Am I clear? So this is what mathematics all about. Okay, we are having some general rules. If any new problem comes, you should know how to reduce it to one of the standard forms. Okay, it comes from practice and understanding the problems. So this is about your combinatorial probability, my dear friends. Now we move on to the next topic, that is addition theorem. Of course, it is the most ignored result, but one of the important result, my dear friends. Okay, see, in the beginning, if you remember, okay, let me just introduce this with one idea. Just a second. There we are. See, when I was discussing the axioms of the probability, there was a result which I given. If A and B are disjoint events, A and B are disjoint events. What do you mean by disjoint events? These two events happen simultaneously at a time, but they do not have any outcomes in common. They are called disjoint events. Then probability of A or B, or probability of A union B, you read it as A or B. Probability of A or B is simply probability of A plus probability of B. Why, sir? Because their intersection is empty, we don't need to consider them. But now this is about disjoint events. Now we need to talk about joint events. What do you mean by joint events, my dear friends? Where the events are having outcomes in common. Here the events are having outcomes in common. Common outcomes. In that case, whenever you need to find probability of A union B, then we need to use addition theorem. See, generally I see people writing this formula blindly. This formula is valid when A and B are disjoint events. That is, if they do not have any outcomes in common. Okay, any outcomes in common. If they do not have any outcomes in common, that is, if they are disjoint, then that formula works. Otherwise, you need to go for addition theorem. Am I clear? See, after addition theorem, from tomorrow onwards, we are going to start with the most important concept, that is conditional probability. But this time I am going to take you to the new level or the next level, where we also discuss one of the machine learning algorithm called naive Bayes. Okay, so that algorithm also I discussed, but today it is like, basic probability part 1. From tomorrow onwards, we start with conditional probability. And that is one of the important concepts. Please don't miss it. Okay. So, of course, it does not mean that miss today's class. This is also important. Questions will come. Nowadays, they are also asking these questions in your aptitude. Am I clear? Now, let us start with this addition theorem. So, we are going to get this addition theorem, or we are going to use this addition theorem when the events are joint events. That is, they have some elements in common. Of course, you can use this theorem when events are disjoint also. It is also applicable for that. We will understand that. Okay. I think there is some, okay, there is some problem with the animation. If A and B are two events, any events, it's not necessary that they are joint event or disjoint events, sir. If A and B are any two events, then probability of A union B, are you able to hear? Is there any problem with the net? If anyone attending, please, let me know. I think suddenly it stopped for some time. Is it working? Let me check my internet once, my dear friends. There is some issue here, I think. Is it, am I live? Because this one, okay. There is some issue, but let me start with this. Okay, once again. I think now I am live. Yeah. Addition theorem. So addition theorem is applicable when the events are joint. That is, they have some outcomes in common. Of course, you can also apply this addition theorem when the events are disjoint also. That disjoint event case becomes a special case of this. So this is the story, my dear friends. If A and B are two events, so here I am not mentioning whether they are joint event or disjoint event, any two events, then probability of A union B is given by the formula probability of A plus probability of B minus probability of A intersection B. See, the idea is like this, my dear friend. This is the set A, this is the set B, and this is universal set. When you are looking for A union B means this entire story, this entire part. Okay. So, when you are finding A, when you are counting A, this entire region is counted. That is, entire A, all the outcomes of A are counted. And when you are counting B, all the outcomes are B are counted. But if you observe this particular portion, this is repeated when B is counted, and it is also repeated when A is counted. That means that common portion, which we call it as A intersection B, is repeated 2 times. That common portion is repeated 2 times. Hope you understand. And because of that, I think there is some issue, sir. I don't know whether. Yeah, I think it's coming. So this particular common portion is counted 2 times, but actually it need to be counted only once. That extra time you are subtracting here. So that is the logic, my dear friend, nothing more than that. So what is probability of A union B, sir? Probability of A plus probability of B minus probability of A intersection B. Because when you are counting A intersection B is counted. When you are counting B, A intersection B is counted again. But each part should be counted only once, but A intersection B you counted twice. Because of that, you are subtracting it. So because of that, this particular formula we are getting. That is, probability of A union B is probability of A plus probability of B minus probability of A intersection B, my dear friends. Because A intersection B is counted twice, when you are counting A and B, you remove once, so that you get exact value of probability of A union B. Is the idea clear, my dear friends? Okay. Now let me introduce different regions in this. So here, this portion is called A and B, whereas this portion is A but not B, or A and sorry to B. This portion is sorry to A and B. That is, A is absent but B is present. Actually, this portion we can also write it like, A minus B. This portion we can also write it like B minus A. Or you can read it like, only A, and you can read it like only B. Now, what about the outside portion? The outside portion is sorry to A and sorry to B. That is neither A nor B. That is neither A nor B. Am I clear? And please note, your universal set is actually sum of A union B plus neither A nor B. This is read as neither A nor B, none. And if you want neither A nor B, how can you get it? Total. That is probability of universal set. What is probability of universal set? That is 1. Sample space, certain event. Universal set becomes certain event. So 1 minus probability of A union B. So this is the formula for this, my dear friends. That is, probability of neither A nor B is equal to 1 minus probability of A union B. And these are the very important formulae. We are going to use these formulae and we are going to solve problems. Got it? And you can extend this for 3 events also. Suppose if you are having 3 events, probability of A union B union C is given by probability of A plus probability of B plus probability of C. So we call them as 1 combinations. All 1 combinations are added. Then all 2 combinations are subtracted. See, it's like 1 combinations added, all the 2 combinations are subtracted, then all 3 combinations are added. If you understand this, you can generalize it for any level. Suppose if you are having 4 events, all 1 combinations added, all 2 combinations with a minus sign, all 3 combinations with plus sign, then all 4 combinations with minus sign. You can generalize it for n events also. All 1 combinations are with plus sign, 2 combinations with minus sign, 3 combinations with plus sign, and so on. Am I clear? So here how many 1 combinations are there? 3C1 1 combinations are there. How many 2 combinations? 3C2, because 3 events, how many 2 combinations? 3C2 2 combinations are there. How many 3 combinations? 3C3, that is 1. So you can easily identify how many such combinations are there. If you write all of them, if you use this formula, you can also find the probability of A union B union C. We generally call it as at least 1. What is it called as? At least 1. A or B or C. That is any one, any 2 of them, all 3 of them also. Because of that, you call it as at least 1, 1 or more. That is the idea. And we also have this particular, Venn diagram. Okay, so here these are the 3 events. Let me remove this. So here we are having different portions. Suppose if you call it as like, A, B and C. See, the innermost part is like A, B, C. All the 3 are present. And if you observe this portion, here A, B present, but which fellow is absent? C is absent. Here if you observe, out of A, B, C, which one is absent? A, C present, B is absent. And if you observe this portion here, out of A, B, C, A is absent. And if you consider this portion, here A present but B, C are absent. Here out of A, B, C, which fellows are absent? A, C are absent. And here out of A, B, C, C present, B and A are absent. And what about outside portion? Sorry to all. Neither A nor B nor C. None. And what about the formula for none, my dear friends? 1 minus, that is total probability, 1 minus probability of this. This portion is called union portion. Is the idea clear? So if you understand this, any problem can be easily solved, my dear friends. Okay, so now let us take up problems to understand how we can handle them. There's a question. The probabilities of occurrence of events F and G are given. Probability of F is 0.3, probability of G is 0.4 respectively. The probability that both events occur simultaneously, that is probability of F intersection G is 0.2. Now the question is, what is the probability of occurrence of at least one of the event? Probability of F union G. Everything is clearly given. He is asking what is probability of F union G. So what is it? Probability of F plus probability of G minus probability of F intersection G. That is 0.3 plus 0.4 minus 0.2, which is 0.5. Straightforward question. Now look at this. In a class of 50 students, so there are 50 students in the class, 60% students, so instead of giving direct number, he is giving in percentages. So total number of students in the class, let us call it as universal set, that is 50. 60% of the students play cricket. What is 60% of the 50? Here cricket it is. So how many people play cricket? 60% of 50. So it is 60% of 50 of. That is 60 by 100 into 50. That is 30. 60% of that is 30. Next, 50% students play football. So how many play football? 50%. 50% of 50 is 25. So I am directly writing it. And 30% play both. 30% means cricket and football. How many people play both of them? 30%. 30% means 30% of 60 or 50. That is 30 by 100 into 50. That is 15. 15 students play both. Now, what is the probability that a student selected at random play both the games? What is the probability that a student selected at random play both the games? C union F. So obviously, probability of C plus probability of F minus probability of C intersection F. And now here cricket playing is 30. What is the probability that student play cricket? Of course, it is directly 60% now. Why to calculate that number, sir? That is 60% now. 30 by 50 is 60%, directly 0.6. Probability that he play football is 50%, that is 0.5. And probability 30% means why to do this, sir? We don't need to calculate those numbers, na? We just need the values. So what is probability of C intersection F? See, this percentage is nothing but probability only, na? 0.3. So what is probability of C, my dear friends? If you want to know the numbers, you can do that. So probability of C directly given 0.6, probability of directly given which is 0.5, and probability of C intersection F, that is 0.3. So this is 0.8. That is 80% of the student play both cricket and football. Now, how many of play none of the games? How many of them play none of the games? None. What do you mean by none? That is, they don't play cricket and they don't play football. So you can write it as 1 minus probability of C union F. So what is it? 1 minus 0.8, which is 0.2. See, my dear friend, in this problem, the percentages are directly given. Of course, I just calculated the numbers for understanding purpose, but it is not necessary in this problem because here we are having total, how many students, sir? 50 students in the school or class, whatever it is. 50 students are there in the school or class. This is 50. And cricket playing students, how many? 30. If you want to know the number, you need to do that. Otherwise, directly 0.6, 60%. And football playing student, 50%. Here, that is 25. How many play both? 15 students. So it is 15 means what about this? 30 minus 15, it is 15. It is 25 means 25 minus 15. How much is this? 10. So if you observe, it is 40. Outside we are having 10. What is 10 out of 50? 20%. So 20% students play none of the games. 20% student play none of the games. See, the advantage of drawing this Venn diagram is if any other question is asked, you can answer them very quickly. For example, if someone asks you, what is the probability that student play only cricket? What is the probability that student play only cricket? See, here I will write two Venn diagrams, sir. One is percentage, the other one is exact number. See, percentage wise, total 100%. This is 60%. This is 50%. Both how much? 30% means this is 30% means how much remaining? 30% here. This is 20%. So 60, 80, 20%. So these are all percentages, sir. Percentage wise, if you want to see, this is what is required. If you want to know the numbers, then this is required. Okay. See, generally probability, we are interested in the percentages only. Okay. Probability of something is how much percentage are playing only cricket. So we are only interested in how many people play only cricket. 30%. That is 0.3. How many people play only football? How many people play only football? 20%. How many people play exactly one game? See, exactly one game means they may be playing only cricket or they may be playing only football. That is, this is what you mean by exactly one. This 30% plus 20%. That is 0.3 plus 0.2, which is nothing but 0.2. So when our probability is asked, this diagram is enough. But if you want to know the numbers, that is for counting, this diagram is important. For probability, this diagram is enough. You don't need to count how many are there. Is the idea clear? Please note that point, my dear friends. Okay, because when they ask probability, you don't need to count these numbers. But sometimes in aptitude, they can ask you how many members are there. In such cases, you need to convert that percentage to that particular you need to convert that particular percentage to number. Of course, after this you can easily convert, sir. 30% of 50, because 100% is nothing but 50 here. So 30% of 50 is how much, sir? You can directly say 15. 30% is 15. 20% is 10. 20% is 10. That can be solved anytime, my dear friends. Because here 100% of 50 is 50. So that you get here. 30% is 15, 30% is 15, 20% is 10 and 20% is 10. That also you can do. Right. Now let us see some important problems. A pair of paired dice is rolled simultaneously. Then find the probability that the sum is 8 or 9. See, we already solved this type of problems because the outcomes which give sum 8 and the outcomes which give sum 9, they are completely different. Can I use addition theorem here? Can I use addition theorem here? Obviously. See, my dear friends, if you observe this particular addition theorem, okay, if A and B are disjoint, then probability of A intersection B will be 0. That is, this part becomes 0. Then what happens to probability of A union B? It is simply probability of A plus probability of. See, of course, this addition theorem can be always used, sir. Only problem is when the events are disjoint, A intersection B is empty. Therefore, probability of A intersection B will be 0. So, probability of A union B becomes probability of A plus probability of B when the events are disjoint. So, don't have to worry about it, sir. Okay, you don't have to study like, disjoint separately and this separately. You can study together. So, what is probability that sum is equal to 8 or 9? Sum is equal to 8 plus probability that sum is equal to 9 minus probability that sum is equal to 8 and sum is equal to 9. See, we can never get any outcomes which gives both sum 8 and 9, sir. So, this is 0. So, total is 36. Sum is equal to 8, how many cases? 5 cases. 9, how many cases? 4 cases, both 0 cases. So, it is 9 upon 36, which is nothing but 1 by 4. Is the idea clear? All of you able to follow? The next one, this was an interesting question. Later on under independent events also I will be discussing this type of, problems. Especially this particular problem I am going to use again when I talk about conditional probability, special problems related to independent events. I am going to discuss this. One very interesting concept. So please remember this. Good for health. Single die is thrown. What is the probability that sum is not equal to 8, neither 8, and sum not equal to 9? Sum is neither 8 nor 9. So it is like, A complement intersection B complement, which is nothing but 1 minus probability that sum is equal to 8 or 9, which we solved just now. So what is the answer? 1 minus 1 by 4, which is 3 by 4. So what is the answer? D is the answer. Is the idea clear? All of you able to follow? Next one. This is a very interesting question. A pair of fairy dice rolled simultaneously. Then find the probability that a sum of 7 or a difference of 1 is obtained. Sum of 7 or a difference of 1 is obtained. Dear friends, you need to understand this carefully. The cases where sum is equal to 7 plus difference is 1, or sum is equal to 7 and difference is equal to 1. Are there any outcomes whose sum is 7 and whose difference is 1 possible? Are there any outcomes whose sum is 7 and whose difference is 1 possible? If you observe 6 and 1, oh, difference 1 you want, na? Okay. Maybe 6 and 1 does not matter. 3, 4, let us take 3, 4. 3, 4 sum is 7. Difference means we are taking absolute difference. Okay, difference means we are taking absolute difference, please note. Or if you want, I'll make it like absolute difference to make it more clear. 3, 4, the sum is 7 and difference is 1. Again 4, 3, sum is 7 and difference is 1. Any other order pair whose sum is 7 and difference is 1? No. So here we need to use this addition theorem. Total 36, sum 7, how many cases, sir? Sum 7, 6 cases. Difference 1, how many cases? Difference of outcomes 1, how many cases? See, we know difference 1 means what? 1, 2, 2, 1. Here difference is 1. 2, 3, 3, 1, 3, 2. 3, 4, 4, 3. 4, 5, 5, 4. And 5, 6, 6, 5. So difference 1 possible for how many cases? 5 cases. Difference 1 possible for how many cases? 5 cases. And both, I'm sorry, not 5, sir. This 2, 2, 10 cases. 5 into 2, 10 cases. 10 cases. Okay. 10 cases difference is 1, my dear friends. 10 cases. And how many cases where both sum is 7 and difference is 1? 2 cases. So what is the probability for this, my dear friends? 8 plus 6, 14 upon 3, 36. 2 7s, 2 18s. So the answer for this problem is 7 by 18. See, my dear friend, when there is some common outcomes, then we need to worry about this intersection part, my dear friend. That plays very, very important role. Now one more interesting question. Now look at this. This is very important problem, sir. This was asked in GATE. Right? A pair of fairy dice rolled simultaneously. Find the probability that sum is divisible by 4 or sum is divisible by 6. See, here I'll just tell you what is divisible by 4 separately, divisible by 6 separately first of all. What do you mean by sum divisible by? I write S for sum. Divisible by 4. Sum divisible by 4 means what, sir? Sum is equal to 4. It is divisible by 4. Or sum is equal to 8. Or sum is equal to 12. See, when sum is 4, 8 or 12, it is divisible by 4, my dear friends. So we are looking for these 3 cases. And these are disjoint cases. I can directly add them. Denominator 36, 4 means 3 cases, 8 means 5 cases, 12 means 1 case. That is 9 upon 36. Now what about sum is divisible by 6, Babu? Sum divisible by 6 means what? Sum is equal to 6 or sum is 12. So how many cases favorable? 36 in the denominator. Numerator, 6 means 5 cases, 12 means 1 case. That is 6 upon 36. Now, when you say sum is divisible by 4 and sum is divisible by 4 or 6, you are saying. If you observe, this 12 is common in both the cases. So there is an intersection between these two events. That is, sum divisible by 4 and sum divisible by 12 are not disjoint event. There are some common outcomes. Am I clear? So when you want to find sum divisible by 4 or sum divisible by 6, what is the story, sir? It is sum divisible by 4 plus sum divisible by 6 minus sum divisible by 4 and 6. So here denominator is 36. Sum divisible by 4, how many cases, sir? We already seen 9 cases. Sum divisible by 6, how many cases? We already seen 6 cases. Sum divisible by 4 and 6. Which fellows are divisible by both 4 and 6? That is only 12. That is one case. So when you do this, 9 plus 5, 14 by 36. So it is 7 by 18 is the required answer. See, actually people say, why you are wasting our time? If you want to solve this problem, there is a simple technique. Okay? Maybe people call it as shortcut also. Sum divisible by 4 or 6. So what are the numbers which are divisible by 4 or 6 or both? So you can directly look at them. So divisible by 4 means what? 4, 8, 12. Divisible by 6 means 6, 12. Already counted. So these are the 4 cases. So what is it? 3 plus 5 plus 5 plus 1 divided by 36. And you got the answer without any trouble. Why wasting time like this? People always have such doubts. Why you need to use this addition theorem, trouble us, think about events and all. Babu, this is important. Here, for 4 and 6, the common and everything, because either you want sum divisible by 4 or sum divisible by 12 means, the common things you can easily visualize. Because for 4, these are the cases favorable. For 6, these are the cases favorable. If anything is repeated, you count only once. But if I ask this similar type of question like this, look at this, sir. Can you do it by the shortcut? I ask this question. Can you do this by the shortcut or not? Please let me know. If you can do it by shortcut, wonderful, sir. One integer is chosen at random from numbers 1 to 1000. So we selected a number from 1 to 1000. So total possibilities. How many ways you can select one integer from 1 to 1000 numbers? 1000 ways. You can select 1, you can select 2 or 1000. Now the question is, what is the probability that the number is divisible by 4 or 6? The number is divisible by 4 or 6. Can you list out and identify which fellows are either divisible by 4 or 6 directly? See, here it is only up to 12. I can say divisible by 4 is 4, 8, 12. Divisible by 6 is 6, 12. This is common, so you count only once. It is done. But here, divisible by 4, how many up to 1000 are there, sir? Can you count it first of all? Can you list it and count it? So this shortcut technique may be possible here, but that is not suitable for this, my dear friends. So you need to understand the importance of addition theorem. So here we need to go for number divisible by 4 plus number divisible by 6 minus number divisible by both 4 and 6. This is important. That is very, very important. Now, how many numbers are divisible by 4, sir? Of course, one second. Sorry for that. So, total denominator, you know, 1000. That is total cases. Divisible by 4. How many are divisible by 4? 1 to 1000. How many are divisible by 4? You can just divide 1000 by 4 and take floor of it. How many are divisible by 6? Divide 1000 by 6 and take floor of it. How many are divisible by both 4 and 6? You can't count directly, no? You can list and count directly. That is very impossible. So that is given by 1000 divided by LCM of 4 and 6. 1000 divided by LCM. Whenever you want to know how many are divisible by both the numbers, total divided by LCM of the numbers you have to take. LCM. And what is LCM of 4, 6, Babu? Least common multiple. What is LCM? That is 12. Okay. So 1000 by 12. So 1000 by 4 means what? 4 2s 8. 250 it is. 6 1s 40. 6 6s 30. 36. 40. 6 6s. Floor means that decimal part is removed. Now 1000 by 12. 1000 divided by this becomes 12. So what is 1000 by 12, sir? 12 8s 96. 40. 12 3s. Got it? Then we have divided by 1000. So simplify to get the required answer, sir. So it is 300, 350, 416 minus 83, or whatever way you do. Okay, please simplify that to get the required answer. 350, 416, 416 minus 83. 311 minus 8 is 333. That is 0.33. So what is the probability that the number is divisible by 4 or 6? See, for this, the addition theorem is compulsory. Maybe for this problem, you can do by addition theorem or you can do directly. My dear friends, whenever you learn any concept, try to take a simple problem so that we can visualize that. We always take simple problem to understand a rule, to understand the rule properly, the details properly. See, some people I always see, whenever it is a small problem, they ignore, they just read it and go. Mathematics, if you do it in air, nothing will happen, sir. You need to put it on the paper. So please do it on the paper. Try to get the results properly. Hope you understand. Right. Now, the story is extended for 3 events. In a certain city, 3 newspapers, A, B, and C are published. Suppose that 60% of the families in the city subscribe to the newspaper A, 40% families subscribe to the newspaper B. So let me draw this Venn diagrams. Let me draw this Venn diagram. There are 3 newspapers. If you want, you can write down what are the newspapers also. I am just calling them as ABC. 60% families subscribe to the newspaper A. 60%. It is percentage, sir, not number. 40% families subscribe to the newspaper B, and 30% subscribe to the newspaper C. 20% families subscribe to both A and B. 10% subscribe to both A and C. 20% subscribe to both B and C. What is important is how many subscribe to all the 3 papers. 5% subscribe to all the 3 papers. See, if you fill this particular Venn diagram, then you can answer the questions very easily, sir. And for the filling this Venn diagram, what is important is all the 3. How many subscribe to all the 3 newspapers? 5%. So this is 5%. I am writing in percentages, sir. The percentage means 5% means how much, sir? 0.05. If you want, you can write like that also. You can just write down this as 0.05. Directly it is in probability. Now A and B 20%. 20% means 0.2. But A and B means this entire portion. Sorry for that. Oh, even this is gone. A and B means this portion. A and B is this portion. And this is 0.2. 20%. So 0.2 already 0.05 is gone. So how much is remaining? 0.15 is remaining. That is only AB but not C. And if you combine this, it is subscribe to A and B. Now how many subscribe to both A and C? A and C, how many people subscribe to Babu? 10%. Out of 10, already 5% gone, remaining 5% here. Now B and C, how many subscribed? B and C, how many subscribed? 20%. Already 5% gone, so remaining 15%. So this is the idea. Now if you see A, total A is 60%. So let us use a different color. For A, if you observe, this total is 60%. But out of 60% here, 25% is already gone. So how much percent is remaining? 35. That is 0.35. Am I clear? Now for B, the total is 40%. Already here 35% is gone. So how much percent remaining? 5% remaining. For C, total percentage is 30. Out of 30, 25 is already gone. So how much is remaining? 0.5. 5% is remaining. That is 0.05. Now if you sum up all this, so this is AC 60%, 65, 80, 85%. So A union B union C is 85%. So how much outside, sir? 15%. So once you fill this Venn diagram, if they ask any question, that can be easily answered, my dear friends. So let me redraw this Venn diagram here. A, B and C. So if you observe A part here, it is only A part is 0.35. AB part is 15%, that is 0.15, and ABC part is 5%. AC part is 5%, BC part is 15%, only B part is 5%, and similarly only C part is 5%. Outside is 15%. Now here they ask question, in this they ask like, what percentage families subscribe to at least one of the newspapers? At least one of the newspapers. See, at least one means what, sir? It is A union B union C. It is A union B union C. Okay. So if you want, you can use the formula method and solve it, sir. That is probability of A plus probability of B plus probability of C minus two combinations, A and B, A and C, B and C. All the two combinations with minus sign. Then three combinations with plus sign. Now A is what, sir? 60%. Percentage, or you can write 0.6, sir. See, if you want directly, no problem, you can write in percentage, later on the percentage, in percentages you can say. Because with decimals, if you are having difficulty, you can write 60%, B is 40%, C is 30%, A and B is 20%, A and C is 10%, B and C is 20%. All the three 5%. So if you simplify, this is 100, 130, 130, this 30 gone, 100, 80, 85. So this is 85%. Am I clear? So what is probability of A union B union C, sir? It is 85%, means 0.85. So what is probability of neither A nor B nor C? Of course, he not asked, but I am just answering that also. This question is done, that is 85% or 0.85. Neither A nor B nor C is 1 minus probability of A union B union C, which is 1 minus 0.85, which is 0.15. If you observe, we already answered that here. If you draw Venn diagram, you can easily answer any question, sir. Suppose if someone asks you, how many taken, what is probability that only subscribe to the newspaper A? 0.35. What is probability that only subscribe to newspaper B? 0.05, yani 5%. What is probability that only subscribe to newspaper C? 0.05. Suppose they ask you question like, what is the probability that subscribe to only A and B but not C? So A and B but not C means what, sir? Which part? So this portion is only AB but not C, which is 0.15. So any question can be easily answered, my dear friend. Once you fill this Venn diagram, any question can be answered without any trouble. And how to fill the Venn diagram, sir? Start with all the three, then two combinations because in 2 combination, if it is given all the 3, if you subtract, the remaining part you are going to get. Then fill these parts, then fill this. Once you fill, any question can be answered very easily. Suppose I ask question, what is the probability of at most 1? At most 1. What do you mean by at most 1, sir? 1 paper, yeah, less. So 1 paper, yeah, less means what, sir? This is 1 and this is 0. So we need to add these 4 values. So what is the answer for this? 0.35 plus 0.05 plus 0.05 plus 0.15. So what is it? 40, 45, 60%, 0.6. At most 1 is that. People can ask you question like, I think I have one more page. Yeah. What is probability of at most 2? At most 2 means what, sir? 2 or less than or equal to 2. So less than or equal to 2 means what, sir? 1 is this, 1 tick, 0, and 2 means this portions. But if you want to solve it, the 4 values plus these 3 values, if you add, you are going to get the answer. But for this, there is a better way of doing it. What is the better way? From total, if you remove all the 3, see, if you remove this inner portion, you get the remaining part. That is 1 minus 0.05, which is 0.9. So any question can be answered once you understand this Venn diagram, my dear friends. So they can ask you at least 1, at least 2. They can ask you what about at least 2. So when you are having this particular diagram, so you see this one, here we are having 0, it is 1, it is 2, and it is 3. So at least 2 means what, sir? At least 2 means what? 2 or more. So this inner portion is at least 2. So you just need to add these 4 cases. So just add those 4 cases, that is 0.15, 0.05 plus 0.05, again plus 0.15, which is nothing but 0.4. So any such question can be easily answered, my dear friend, once you understand Venn diagram. Is the idea clear? Now, before moving on to the next problem, for those who do not know about cards, let me quickly introduce cards for you. Okay, cards. So generally we call them as pack of cards. So there are totally 52 cards. So we don't have jokers in mathematics. Okay, some people might be thinking about jokers. No jokers in mathematics. Please note that. Right? And we have these 52 cards divided into 4 shoots. They are divided into 4 shoots. Out of the 4 shoots, 2 shoots, out of 4 shoots, 2 shoots are red in color. Heart and diamond are red in color. And of course, black, if I write, I think you cannot see. So I need to show them in some other color. So I'm just showing them in blue, but assume that that is black. Very strange, no? That is spade and club. Assume that they are black in color. Am I clear? So this is called diamond. And this is, what is it? Red. Sorry. What I am writing, sir, this is heart and this is diamond. This is heart and this is diamond. See, after seeing, the blue color for black cards, I am getting confusion. Now this is the spade and this is the club. Is the idea clear? So now you are having these cards and these are called shoots, 4 shoots. We are having 4 shoots. And in each shoot we are having ace. We are having ace. Numbers 2 to 10. Jack, queen, and king. So this jack, queen, king are also known as face cards. These are the numbers and that is ace. So each shoot we are having 13 cards, my dear friends. So those who do not know about it, please note it. Now here, 2 cards are drawn from pack of 52 cards. So first of all, how can you select 2 cards from pack of 52 cards, sir? We can select 2 cards from pack of 52 cards in 52 C2 ways. 52 C2 ways. Now the question is, what is the probability that they are both kings? The 2 selected cards are kings. Now tell me how many kings are there? We are having 4 kings. So denominator is 52 C2 and the numerator is, because how many kings are there? 4. From that, how many you are selecting? 2. Because both the cards which are selected are kings. That can be done in 4 C2 ways. Both the cards are hearts. So hearts means how many hearts are there, sir? There are 13 hearts. So 52 C2 total favorable. Out of 13 you have to select 2 cards, 13 C2. That is answer. Now next question, 2 cards are drawn from pack of 52 cards. So what is total possibilities, my dear friends? How many ways you can select 2 cards from pack of 52 cards? 52 C2 ways. Now what is the probability that both kings are both aces? Both the cards are kings or both the cards are aces. Now if you observe, let me remove these unnecessary things. You want both kings or both aces? Kings and aces. And if you observe, there is nothing common between them. So these are disjoint events. These are disjoint events. So both kings or both aces, it is same as probability that both kings plus probability that both aces. So denominator is 52 C2. Kings, 4 kings, you need to select 2. Aces, 4 aces are there, we need to select 2. 4 C2 plus 4 C2. That is answer. What is the probability that both are black cards or both are kings? Both are black cards or both are kings. Now if you observe, how many black cards are there, sir? 26 black cards are there. How many kings are there? 4 kings are there. Are they disjoint or they are having something in common? They are having some elements in common. So here we need to use the addition theorem properly. So what happens to this? So it is probability that both black plus probability that both kings minus probability that both king and black. So denominator is anyhow 52 C2. Tell me both black. Total, how many black cards are there? 26. From that you need to select 2 black cards. How many kings are there? 4. From that how many you need to select? 2. Now tell me king and black, how many cards are there? King and black we are having 2 cards. So from 2 you need to select 2 cards. So that is the probability of selecting both black or both kings. That is the probability for selecting both black or both kings. Very good. Now what about the probability that both are hearts or both are kings? Now if you observe hearts and kings, just remove this. So for hearts and kings, these are the hearts and these are the kings. So it looks like they are having something in common. So you might feel like, it is same as probability that both hearts plus probability that both kings minus probability that both hearts and kings. So denominator is 52 C2. Here both hearts means how many hearts are there? 4. You have to select 2, that is 4 C2. Both kings means, hearts 13, no? There are 13 hearts. Don't change that. There are 13 hearts, so you can select 2 cards in 13 C2 ways. Both kings, 4 kings, you need to select 2 kings. Now here, both heart and king. How many cards are both heart and king? How many cards are both heart and king, sir? There is only one card which is both heart and king. From one card, you need to select 2 cards. From one card, you need to select two cards. How can you select two cards from one card? Are you going to tear it? That is impossible. That is 0. It is 1C2. From one, you need to select two cards, which is not possible. See, actually, when you are taking two combinations, okay, when you are taking two combination, even though it looks like they are having something in common, here we are seeing one combinations. But in two combination, these two events are not having anything in common. If you are taking one combination, these two events are having outcome in common. But when you take two cards, that two card selections, if you write down the two events, that is heart and king, they have nothing in common. Because of that, this intersection part is 0. Or if you want, you can just do from one card, you need to select two cards, which is impossible, 0 answer. Like that, you can answer it. So what is the answer for this, sir? In 13, 15 to 6. Right. This is the answer. You can simplify to get the required answer. So these are some problems, standard problems on addition theorem, my dear friends. So this is the homework for you. Please try this, a very, very interesting problem. Please try this problem, homework problem. Am I clear? If you get the answer, write in the comment box. If someone write the answer, someone is trying, then I try to provide answer for this. Otherwise, these are all open-ended questions, my dear friends. So I'll be giving some open questions, challenging questions towards the end of the class. If you try to write some answer, right or wrong, it does not matter. If you can provide answers in the comment box, if they are wrong or right, okay, I think that people are trying it, then I try to provide. Okay, otherwise it's difficult to get the solution for, okay, every problem, my dear friends. Okay, this is a very interesting problem. Please try that. So we conclude addition theorem here. So far, what we done, sir? We started with basic probability. Where we understand probability definition. Of course, before that we understand what is random experiment, what is sample space, what is event. Then we understand what is the definition of probability of an event, favorable by total. Then we understand how to find probability of an event by general, like listing method or common sense methods. Then we understood how to find probability of event using counting techniques, combinatorial probability we call it. Okay, probability using counting technique. So we done it in two parts. Actually today also one part we done it. Okay, so two parts we done it. Then today we done addition theorem, my dear friends. So under that probability using counting techniques, we try to understand permutations without repetitions, combinations without repetitions, permutations with repetitions, permutations with constrained repetitions, and combinations with repetition formulae also. Am I clear? And we also completed addition theorem. So the next part is very, very important. From here onwards, the concepts are very, very important. Actually speaking, for most of the branches, the probability syllabus is given from here only. That is, we are having this, multiplication theorem and conditional probability. Actually, you can call this entire topic as conditional probability. Everything which you are doing is under conditional probability. So we do conditional probability, multiplication theorem. Okay, how to handle when the events are independent, how to handle when the events are dependent events. That is multiplication theorem with independent events, multiplication theorem with dependent events. Then we learn the total probability and Bayes theorem, and we also try to see one of the machine learning algorithm, that is naive Bayes. That is Bayes theorem only, sir. That particular result also we try to understand. Am I clear? So we start conditional probability from tomorrow. This part will be starting from tomorrow. Okay. So if you are having any doubts, you can ask me. Otherwise, that's all for today. Okay. So you can share this session with your friends so that they can get benefit out of it. That's all for today. Thank you, my dear friends.